Hello students. In today's video lecture of machine drawing, I would like to start off with assembly drawings, where the first one is stuffing box machine drawing, and we are going to deal with assembly, which is a very much important topic. Out of your part A and part B of machine drawing syllabus, I am trying to cover the part B syllabus, which completely deals with assembly drawings. What is an assembly drawing? Is all about placing all the components in its working position. Okay, there will be an assembly where you have a major part or a body, and sub parts will come and assemble into that particular main body. So we'll try to assemble them based on the working position. Fine, based on the working position. We have some 10 to 12 assemblies need to be covered in this particular videos where you have in your syllabus. Now firstly, I'll start off with stuffing box. Very much important one, mostly repeated in external examinations. Okay. Now what is a stuffing box? Acts as a leak proof valve. Okay, which will prevent the loss of fluid. Which it acts as a what? Leak proof valve in some machine assembly. Okay. In between a sliding or a turning part. In between what? A sliding or a turning part in actual practice. Okay, which will prevents leakage of steam from the cylinder. Fine. Now no need to write the application point when it comes to examination. Simply we need to draw complete assembly with whatever the specifications given. Complete question will be given to you with all the specifications. You need to redraw them in an assemble way. Fine. So for example, the stuffing box has some 5 to 6 parts. I'll explain each and every part initially. For example, part number 1, the shape is something like this. Have a look at the shape. Now it is maintaining a thickness of 15 mm, here also 15 mm. In between there is a height of 55.0, and out there is a length given as 120. Fine. From center of hole to center of hole, there is one more dimension given, which is again 84. Okay. This is about part number 1. I am giving you the major dimensions. Here it is maintaining 15. Here I am trying to draw a zigzag line, which indicates that it is a conventional thing. Now you can take more than 120. You can draw a rectangular plate of more than 120. That is according to your wish or according to the space availability. Based on the working conditions or the foundation, it will change. Okay. So why we are drawing this zigzag line? This zigzag indicates that the size could be more or less compared to 120. It could be more or less. There won't be any exact value given. Fine. There is a hole drill which is of diameter, internal hole of diameter 42. Okay. And there is an outer diameter of 60. Okay. This is about your part number 1. And there are 2 holes drilled on both sides of the vertical axis line. This is the setup given in your question. Fine. I'm giving you the major dimensions which you are going to deal with. Now if I asked you to find the whole diameter, you could see in the top view of part number 1. The part number 1 top view is something like this given in your question. Okay, where you have a smaller holes with again 42 dia. Okay, now this is maintaining a diameter of 12. From the center again, this is maintaining a radius of 18. Okay, now this is your axis line. From some point from here to this point, there is a radius of 75. How much? There is a radius of 75. Now I'll tell you how to draw these radiuses and this radius of 18 and 12 in the assembly part. Fine. This is about the arrangement given. And again you have one more part, which is part number 2, something like this. Again it is having a elliptical cross sectional plate with a head and with one more base. Fine. Which is maintaining a hole, okay, of again 13 mm. This time the diameter of 13 mm. Okay, which is having an outer of 50 dia, height of 9. Have a look. This is your component. Now internally there is a hole of how much? 24 dia, 24 diameter. Okay, this outer dimensions are diameter is equal to 42. Okay, now this out and out length is again 120. Out and out from center to center of the hole dimensions are given, again it has 84. Okay, now with these specifications 120, 84 matching with 120, 84. Okay, now I can say blindly that this part is going to sit over part number. One more question is, will it sit directly or there is some arrangement given? Because there are few more parts given, part number 3, part number 4, part number 5. Okay, and there will be a table given, and part number 1 is made of which material, what is the quantity of part number 1. Similarly, part number 4 made of which material, what is the quantity of part number 4. All the specifications, all the information is given in your question. You need to only know how to fix them. That is the most important task. Fine. Now coming to part number 3 is something like this. Roughly I'll make a note, something like this. Okay, which is having an internal diameter of 24. Out and out the diameter is given 33. Fine. And here the outer diameter is again 42. Now this 42 is matching with this 42 as well as the whole 42 of part number 1. Fine. This 42 is matched to external dia, part number 1 internal dia. So we can easily say that this part number 1 going to sit inside part number 1, completely inside, which is not visible to us once we insert it. Fine. And part number 2 is again having some leading edges like part number 1, so it is not going to sit completely inside. Okay, there is a provision that it may insert up to this level. What is this level given? There is a length of 45 here. There is a length of 45 given. So there is a chance that it may insert up to 45. But again, there is a constraint again, because there is part number 4 again. Part number 4 contains a stud maybe of this kind. Okay, the quantity. What is the quantity of stud? 2. Given drawing, where to start drawing the sketch. Whatever the assembly may be, try to start off with part number 1, which will give you most of the information of that particular assembly. Okay, other parts other than part number 1 are sub-assemblies. Okay, will come and sit in that particular part number 1 for whatever the assembly you deal with. Okay, so firstly start off with part number 1. Fine, according to the dimensions. One more point I would like to mention: before you try to lay out, check your space availability of your drawing sheet. So I have some less space available here, whereas in your case you may given a A3 sheet, complete A3 sheet. Here I have very less space where I am going to draw with my free hand. I am not using any drafter, so I'll try to wind up things just in this particular space. Okay, but you have to lay out properly. What is layout? Now what is the major height of part number 1, what is the major height of part number 2? If you add things like this is thickness of 15 plus 50 plus 15. Okay, overall there is a height of 80 mm. Again 45 plus 15, there is again a height of 60. Fine. So there is stud going to sit over. So altogether you can go up to 180 or 200 mm. Whether I can place the front view here with that 180 200 mm or not. Okay, it is not exactly, but still you have to take some rough estimation and plan your things, because once you draw you can't erase it. It is waste of time, because again you need to draw the top view. Top view major dimension, the width is going to be 72 plus or minus. You can add some plus up to 20 or 30 mm. That will give you your top view. So try to have space for front and top both. Okay, once you draw the front view, if you don't have space for the top, then it is waste of your time. You will lose your marks. So layout is more important. One more point is scaling of your component. Whether you could fix your complete assembly front view, top view in your drawing sheet or not is a very big question. Sometimes what happens, you deal with bigger assemblies like eccentricity, screw jack. In such cases the dimensions are very much bigger. In such cases what happens, if you use A3 sheet also, it is not sufficient. In such case what we try to do is, we will try to take the dimension in 1:2 ratio. What does it indicate? For example, I have a rectangular box of 1000 meters by 500 meters, which is not easy to place. I need to place this kind of components, some 3 or 4 in my A3 drawing sheet, which is not at all possible in A3 sheet. What we try to do, we will try to divide whatever the dimensions we have with 2, 1:2. We will try to scale down it. What we have learned from engineering graphics or engineering drawing, scaling down. Okay, so you can scale down the object if the size of the object is very much bigger. The best example is a building, big building you can lay out in your drawing sheet. Okay, so 1:2 or 1:3 or 1:4 or 1:5, scaling down. Okay, mostly we'll go with 1:2. If you make it as 2:1 or 2:3, what happens? 3:1, 4:1, nothing but an enlarged scale. If this becomes in a reverse way, 2:1 means enlarged scale. This is enlarged scale. This is what? Reduced scale. Fine. So in this case, space availability, if space availability is sufficient, directly I'll start off with drawing a sketch. Fine. Now initially what I try to do is I'll try to draw one vertical. This is vertical axis line somewhere in the space availability of my drawing sheet. Then again, to draw the first part number 1, I'll take one more horizontal axis line. Okay, conventionally I'm planning myself because I need to draw the top view here. So this space is available for front part number 1, then again some more part going to sit over, then again top view going to be here where I am drawing with my free hand. Fine. Now try to concentrate. Now whatever the assembly may be, try to draw the part number 1. As I said, what I try to do is, initially there are dimensions, major dimensions of 120, 84, 42. Okay, I'll try to divide this 120 into 2 halves, 84 into 2 halves, 42 into 2 halves, 66 into 2 halves. Okay, I'll come from center point to, I'll try to explore the view. Fine. Now 66 divided by 2, 33 on both sides of your vertical axis line, 33, 66, 33, maintaining a height of what? 50 mm. So from here I'll try to maintain a height of 25. Okay, because the overall height of 66 diameter is 50. That is the reason I'm taking it as what? 25, 25. Symmetrical on both the sides. Again 25. Again bottom also 25. Okay. Then again there is a width of 15 mm which is having length of 120. Major length of 120. So I'll try to place something like this. I'll try to close it. Okay. So from the center I'll make a mark of 60. From the center again I'll make a mark of 60. Okay, so overall it is going to be 120, which is maintaining a thickness of 15. Again I'll try to close the box. Okay, bottom there is a rectangular plate, as I said initially. It is going to be more than 120. Try to close it. Try to increase the length by more than 60. That could be 80 mm both the sides of the vertical, and close with a zigzag line, which indicates that there is some more part left over, or you can enlarge the part, you can increase the length also, not a problem. It all depends on the working conditions. Okay, and one more thing is, part number 1 is having an internal hole of how much? 42. So 21 from the vertical, 21 from this is going to be your part number 1. Again from the center to this particular hole of diameter 12 mm, there is a distance of 84 by 2. Okay, which is 42 from the center. From here 42. I'll try to draw an axis line. I'll try to draw one more axis line. Okay, try to understand. Now here this is how much? 66. This is 66 dia. Okay, this is maintaining a width of 15. This is also maintaining 15. Okay, internal hole of diameter 42. Okay, there is one more hole somewhere here in the bottom, which is maintaining a hole diameter of 33, just to make you understand. Okay, now in between this axis to this axis it is going to be 84. From end line to this end vertical line it is going to be 120. Okay, now I'll take part number 3, which is bush, somewhere here. Okay, now to place part number 3, I'll from the top till the bottom, because the leading edges are maintaining a diameter of 42 and a smaller diameter of 33. So this 33 is matching with this 33, so it is going to sit in between. Okay, if you place the part from top to bottom, it is going to sit something like this. This is part number 3. Okay, similarly I'll take part number 4, which is stud. Okay, stud is maintaining a length of overall height of 90 mm, and there is a threading up to 58. Okay, and a bottom threading and a diameter of 12 and 15 length. Okay, so I'll try to place the stud here. For example, if this is your stud, you can place it from top to bottom, something like this. So bottom 15 is matching with this 15 mm. Bottom 15 of stud is matching with this 15 mm, and the remaining length will come above the part number 1. Okay, if that is matching with this, so internally what happens is going to sit something like this with a curve in the bottom. Okay, then again there is a rectangular plate which will sit over part number 1. which is of diameter 24 by 5. So this width is 5, this dia is 24. Okay, and it is maintaining a length of 90 from this horizontal till the end. So from this horizontal, try to measure 90. So accordingly, try to draw that 90. Okay, close with a flat curve. Okay, and one more point is, here there is a threading up to 58. Draw one more line, continuous line, okay, till 58 distance from the top. I'll repeat, have a look. It is going to be 12, it is going to close 24 by 5. Then again there is a continuous line till 90 from the horizontal. I'll close the line. Then there is a threading from the top, something like this. Okay. Now this threading gap you maintain up to 1, that is enough, 1 mm both the sides. Okay. From top to bottom it is going, top to this point it is going to be 58 according to your question. Okay. This is how you place your studs. After this, take part number 2. You can place your part number 2 simply from here. For example, if I place part number 2 from the top, I can place it here, I can rest it here. If I rest part number 2 leading edge here, what happens? It is going to suspend in the air. Complete thing going to suspend in the air, and it doesn't look like an assembly. Then what we try to do, we'll try to take this horizontal, complete horizontal, to match up with end point of 58 threading. We'll try to match up this horizontal bottom with end point of 58 threading. So this, if you take this as 0, here at the end 58, till 58 you have threading, try to fasten till 58, start your line somewhere here, take a horizontal. Okay, now this distance 120 is again equal to this distance 120, try to match up with this line, and again it is also maintaining 15 mm gap or thickness, try to maintain that 15 mm thickness, align with this vertical, close it. Okay, again part number 2 is maintaining a depth of 45. So from here try to measure a depth of 45. Now this 45 again matching with this 45, there is a whole 45 in part number 1. So simply what you try to do is, try to draw a vertical. From here 40, 21 from the center, 21 draw vertical. Okay, now whenever it insert into part number 1, what happens? There will be a hidden line, something like this. Okay, on the top there is a head of 50 by 90. From here make a mark of 25, 9 mm height, 25 width, close it, something like this. Fine, this is part number 2, part number 1, part number 3, part number 4. Now to fix these completely, fix this setup completely, what we try to do is, we'll try to take a nut, hexagonal nut. Initially we learned in the previous topics, like what are the dimensions of hexagonal nut? Dimensions of hexagonal nut is having diameter of 12, because the diameter here is given is 12. Then what is W? W going to be 2D, that is going to 24. What is R? 1.5D. These are the standard dimensions given for hexagonal nut. Similar thing has to be followed here. Simply just try to follow this 12 and 24, then you can draw a perfect, what you call, hexagonal nut over. Okay, so as this is maintaining 12 diameter, now from here you can make a mark of, W is going to be 24, from the center make a mark of 12 on both sides of the vertical. Then T is equal to D. What is D? 12 mm. From here draw 12 mm height, close it with a rectangular box. Okay, similarly from the center, I am repeating again, from the center make a mark of 12 on both sides of the vertical and a height of 12, close it. Okay, from here to here it is going to 24, because W is equal to 24. This diameter is 12, height is also 12, because T is equal to D. Fine. After drawing this with free hand, try to draw curves. Okay, because in this small area you can't place this R is equal to 1.5D. So simply with free hand try to place it. This hexagonal nut will not be given you a question most of the times. You have to imagine by your own. Okay, this is the arrangement. As I said initially, it is a leak proof valve. There is a liquid filled in this area. There is a liquid filled in this area. From top to bottom there will be a shaft. Why minimum? For example, in this case 33 is maintaining a minimum diameter of 24 internally. Have a look. I'll try to enlarge the view. Internally it is maintaining a gap of this much. So try to insert a shaft from top to bottom, circular shaft. From here it is visible, from here it is visible. Make it a sectional view. Okay, there will be a shaft from top to bottom which will have a reciprocating motion which will help to leak proof that particular valve. Okay, here it is filled with fluid. This is the arrangement you need to draw. No need to talk about the application point in your examination. Okay, after drawing everything, top view of the component is very much important. Top view of the component is almost equivalent to top view of part number 1. Whatever you have drawn here is going to come here. This will be given your question. Okay, I'll try to make the top view, try to have a look. So I'll take the projections of this one and try to close it. Okay, I'll make it in a zigzag way, not a straight line. Why? Because it is conventional. Okay, you can draw by your own. I'll try to make a center point. Fine. Then when I view from the top, what is visible? I could see circle of diameter 24, circle of diameter 50 and two 12 mm diameters. Then there is a hexagon visible to us from the top, and there is an ellipse from this end to this end. Ellipse is visible. So in the top view of part number 1, the width, major, minor dimensions of ellipse are given. Okay, top view, have a look. Now when I view from the top, I could see 24 dia, I could see 50 dia. If I take these projections, I can draw this 12 mm circle is visible, 12 mm circle is visible. Okay, and there is a hexagon that is also visible. We will draw it later on. Now from this information of top view part number 1, you can take this as center, R12 with the help of this as center, R12 as radius. With the help of compass, you can draw a semicircle of this kind. I'm repeating, R18 semicircle. Okay, now one more dimension is given, which is R75. Somewhere on the vertical center is given. So how to measure that? Overall dimensions, this width is given, which is 72. Width is 72 given already. So what you could do is, from the center, I'll try to make a mark of 72, which is 36. From here, 36. Your ellipse is going to end up at this particular 2 points, minor dimension, which I am calling it as. Okay, one more radius 75 is given. From the center, 75 divided by 2. From the center, make a mark of that thing. So 3 mm more than that. From here, 3 mm, because already 73 is marked. 3 mm is more than that. I'll make a mark of that. Okay. Now this is 75 marking. This is 73 marking. Sorry. Okay. Now taking this as center with the help of compass. 75 as center with the help of compass and radius of 75. Try to draw a curve, something like this. Okay. And this as center. Take this as C1, this as C2. Again 75 radius. Try to draw this curve. Okay. Here ends the ellipse. In actual practice, what happens when you draw with your drafter, this curve 18 will go this way. This curve ellipse will go this way. So you need to manage with the help of freehand, which is very much useful. Okay. Now after this, you have to place all the dimensions with an arrowhead. Now arrowhead need to be filled. This is all you know. Okay. After this, you need to place bomb balloons, what we call bomb balloons. Nothing but here you need to place part number. Okay. This we call it as leader line. Draw with a scale by using a drafter or a scale. Then again place the number 4. This is part number 1. This is part number. Now this has to be horizontal always. Horizontal. The inclination could be anything. Okay. This is your part number 3. Try to align all the circles also, then you will get a proper picture. This is the front view, this is the top view of your assembly. Okay. Now here it is maintaining a dimension of 72, overall dimension of 120. Okay. This is the assembly of a stuffing box, where everything will be given with the help of dimension. Everything will be given to you in the question. So accordingly you need to assemble them all. Finally you need to give numbering, dimensioning. Afterwards you need to draw the table also, whatever given in the question, table with serial number, part number, quantity, material it is made of. Okay, what is the table given, that has to be drawn to the right bottom corner along with scaling and units. Never place units. For example, 15 mm, never place units here. 15 mm, this is wrong. Try to place the units here itself, saying that all the dimensions are in millimeters. That is enough. Okay, if you scale down, then you need to write the scaling as 1:2. If not, don't write anything. Okay. If you scale down for few assemblies also, try to write the actual number only. Don't try to write the number which you got after division. Okay. This is about a stuffing box assembly. Thank you.